Okay, this is lesson 9.6. This is our problem solving lesson. So, if you remember from the rest of the year, the problem solving lesson, it's always about word problems and using a problem solving strategy to help us solve those word problems. The problem solving strategy we're going to use this lesson is called solving a simpler problem, a simpler problem, an easier problem. And I'm actually going to have us draw tables. We learned in lesson 5 how to use a table to find a rule, and we're going to be finding rules. So we're going to use that table. It's a little simpler than you think, right? Okay, let's unlock this problem. So it says, on an archaeological dig, Gabe separates his dig site into sections with areas of 15 square feet each. There are 3 archaeology members digging in every section. What is the area of the dig site if 21 members are digging at one time? All right, so usually with word problems, we circle our numbers. We underline our question. Okay, it wants us to find out how big is the dig site if there's 21 members digging in it. We know that there's 3 members in each section. Okay, and each section is 15 square feet each. Let's see, we could box our keywords. There is each, but I don't want you guys to confuse that we're going to multiply, these numbers. We need to find what the pattern is. So that's why we have our table set up and we're going to find the rule. It's a lot like lesson 5, like lesson 5, where we looked at the patterns in the table and we looked for a rule. We're going to do the same thing. Okay, but now our table's completely blank. We've got to fill in what we are making this table about and then find the rule. Okay, all right, so let's see. They're doing sections. So sections, I'm going to make that, it's going to be like section 1, section 2, okay? So there's section 1, there's going to be section 2, section 3, right? Section 4, maybe I'll fill in those ones. And then I'm going to do the dot, 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 because I want to find out how many sections with 21 members, but I've got to get my pattern going first to see what these numbers are going to be, how many sections, and then the 21 members. Okay, so in one section, let's see, we know that there's 3 people in each section, right? 3 archaeology members are digging in every section. So we'll make this first category members, right? Members. Okay, and in that first section, there's 3 members, right? Okay, so what could the last line be? Go back to our word problem. The other number we have, like 21 is what we want to find out when there's 21 members. So we're going to bring this out to 21. We're going to want to find when this is 21 over here. The other number we have is 15. Okay, so 15 square feet is the area of each section. It says right here, Gabe separates his dig site into sections with areas of 15 square feet each. So we'll make this area. Okay, area, and that's going to be in square feet. And section 1 with 3 members is 15 square feet because they're 15 square feet each. All right. So there's the beginning of our table. Now we've got to look at if there's 2 sections, if there's 3 sections. So if there's 3 members in each section, if there's 2 sections, then that means 6 members. There's going to be 3 in one and 3 in the other, right? And then if there's 2 sections, there's going to be 15 and 15. There's going to be 15 one section, 15 on another section for the area. So that makes 30. All right. Now imagine 3 sections of the archaeological dig. Okay, if there's 3 people in each of the sections and there's 3 sections, then 3 times 3 is 9, right? If there's 15 square feet in each section and there's 3 sections, remember this is our 3 column, then that would be 45, because add 15 to the 30, right? And then if there's 4 sections on the archaeological dig, it's getting bigger and bigger, and the numbers are getting bigger and bigger, but that's okay. We're looking for a pattern, okay? We're looking to see what's going on here. All right, so 4 sections of the dig sites, or 4 separate dig sites. There's 3 in each one. That means that 12 members will be in the 4 sites, 3 in each one. And then how big are those 4 sites? Well, if they're 15 square feet each, that would be 60. Okay, 60 square feet for 4 sites. All right, so now let's look for some rules, some patterns. What are they doing with these numbers? So I'm going to get a different color. Let's start with the first one. Okay, this one's actually, you see a pattern going for both. Remember, we do want to find this one. We want to find, how do we get from the members, because we have the members in our question, 21 members. So I'm going to actually put that right here, 21 members. We want to answer this. It says, what is the area of the dig site if 21 members are digging at one time? So we want to find this area number. I don't know how many sections for 21 yet. I can probably work backwards and figure that out using the same patterns here, okay? But we'll get to that in a second. All right, so going back over here, from 3 to 15, from 6 to 30, from 9 to 45, and from 12 to 60. Do you see a rule? Do you see a pattern? How do I get from 3 to 15? How do I get from 6 to 30? And remember, it has to be the same rule. It has to be doing the same thing. Okay, so 3 times what makes 15? Times 5, right? Okay, does that work for this one? 6 times 5 makes 30? Yes, it does. Times 5. Does that work for this one? 9 times 5 is 45? Yes. 12 times 5 is 60? Yes. So our rule is to multiply by 5, right? So we found the rule. We're going to write that right here. Okay, multiply the member. Remember, we're going to multiply this top number. We multiplied the 3 to get this. We multiplied the 6 to get this. And those were our member numbers. Multiply the member number by 5. And when we do that, it finds what? It finds the bottom number, which is the area. Sorry, the bottom number, the area. So multiply by 5 to find the area of the dig site, Ooh. There we go. Okay, so we found the rule. Not done. We still got to answer the question. The question says, what is the area of the dig site that has 21 members? So we need to find this number right here. Okay, so that means I need to take my rule, which was times 5, and apply it to 21 members, because it says multiply the members. They're the member number, 21, in our question, 21 members, by 5 to find the area. And that's what we need to find. What is the area? Okay, so 21 times 5, I can do that mental math, can you? If not, I'll do some side work. 21 times 5, 5 times 1 is 5, 5 times 2 is 10. That's 105. Okay, and our answer to the question, the one in our problem, what is the area of the dig site if 21 members are digging at one time? We're going to put our answer. The dig site is 105 square feet. And that's our answer. Okay. All right. And that's unlocking the problem. So just to recap, we use the information in the word problem to make a table. We've got to organize our information. And then, like yesterday, we're going to use those table numbers to make a rule. And then with the rule, we can answer the question that they gave us, the underlined question that we had in the word problem. All right, let's try some more. Okay, let's go up here to example 1. It says, example 1, Jane works as a limo driver. She earns $50 for every 2-hour shift. How much does Jane earn in 1 week if she works 40 hours? All right, so we got lots of numbers in here. We've got $50. We've got 2-hour shifts. And then our question wants us to find out how much money she'd make if her shifts equaled 40 hours. Okay, so we're going to use these two. 2 and 50 are going to start off our table. And then the one where the numbers in the question, this is going to be what we solve at the end after we find the rule. So we're going to use 2 and 50 to find the rule. And then we're going to use this one to answer the question. Okay, so let's start our table. What is it going to be about? So it's a limo driver, working shifts, and earning money. So let's have this one be shift. Okay, so shift 1, right? Shift 1 is 2 hours long, so this will be hours. So every shift, every 2-hour shift. So one shift is 2 hours, and then money, I'm going to put dollar signs. How much money does she make in 2 hours? We look at our word problem, and it's right there, $50. So there's our first let's say, entry into the table. In one shift, Jane works 2 hours and makes $50. Okay, and let's make this go a little longer. Let's bring it to 2 shifts and 3 shifts and see if we can find a pattern. And then we'll skip it to the question. Okay, ... remember means it's skipping some numbers. Okay, after we find the rule. All right, so let's say she does 2 shifts. Well, with one shift, she worked 2 hours because they're 2-hour shifts each. So in 2 shifts, she would work 4 hours, right? 2 and 2 makes 4. Okay, and if she works 2 shifts and she makes $50 for each 2-hour shift, then that means 50 plus 50, so she'll make $100. Okay, 3 shifts would be 2 more hours on top of the 2 shifts, so 6. And then 50 more bucks, right? So add 50 to that and we get 150. Okay, so it's kind of like our table starts off as like a sequence, 2, 4, 6, right? And then 4 would be 8 and 10 would be 5 and so on. Okay, it would take me a long time to get to 40, right? If I want hours to eventually get to 40, this table would be super long. It would go on because it's going to take me a long time counting by 2s to get to 40. So that's why the rule really helps too. I mean, you could make a super long table, but it will take a lot of time. Okay, so that's why once we have like a few of the patterns going, so we have our hours are going up by 2s, our money is going up by $50 each shift she works. Once we find this pattern, once we find out, how does it get from 2 to 50? How does it get from 4 to 100? How does it get from 6 to 150? Once we find that rule times something, right? It's getting bigger, so it's probably multiply. Okay, once we find that rule, then we can use it to help us solve this question. How much money does she earn in 40 hours? So this is going to be 40 on the hours, and we need to find this number down here, right? We need to find out the money. Okay, all right, so find the rule first. How do we get from 2 to 50? What would I multiply 2 by to get 50? These are big numbers, bigger than we've seen yet. Okay, let's see, 2 to get to 50. If you're not sure, if you can't do that mental math, you could absolutely do the opposite, which is divide. You could do 50 divided by 2 to help you find out how much was multiplied to get to 50, right? You're using the inverse operation to figure it out. You could also do 100 divided by 4 to see what this is, because remember, those are fact families. So when I multiply 2 numbers and I get a product, I can check my answer by dividing, right? I can divide backwards and see if I get that dividend or that quotient that matches one of my multiples. Okay, so 2 times, it's actually going to be 25. And I think of quarters too. 25 and 2 quarters, right? Quarters are 25 cents is 50 cents. Okay, 4 quarters is 100 cents, right? $1. So it's 25. 6 quarters. 6 times 25, is that 150? Think of quarters, okay? 6 quarters, 4 of them would be 100, right? And then 2 more would be 50. So yes, it does work. So our rule is times by 25. All right, so let's write the rule. Multiply. Multiply what? So multiply blank by 25 to find blank. What am I multiplying by 25? A little fuzzball there, sorry. Okay, what am I multiplying by 25 to find the next number? Remember, I'm working from top to bottom. So I'm multiplying 2 by 25 to get 50. I'm multiplying 4 by 25 to get 100. So those numbers on the top are the hours. So multiply the hours by 25 to find, what do these numbers represent? It represents the dollar bills, right? To find, let's put the amount paid or earned. It could have been earned. Okay, almost done. We're not just writing the rule. Now we have to answer this question, right? How much does Jane earn in 1 week if she works 40 hours? So we got 40 on the hours line. We've got to times it by 25 to find out how much money she earned. I definitely need to do side work on this one. Actually, I don't. But I will, because some of us will need it. So 40 times 25. I'm going to squeeze it in right here. I'm just going to put the 40 right here. And because remember, multiplying, it doesn't matter which one's on top, right? Okay, 0 times 5 is 0. 0 times 2 is 0. Then we put our placeholder 0. I call him Bob. And now we do our 4. 4 times 5 is 20. 0, carry the 2. 4 times 2 is 8. Plus 2 is 10. And then we add these up. And it looks like I'm getting 1,000. So Jane is going to earn $1,000. Nice. In 1 week of driving a limo. Okay, I'm going to put my answer right here next to the question. How much money does Jane earn? Jane earns $1,000. There we go. All right, example 1 is done. Last one for today is example 2. We're going to use the same steps. We're going to use the information in this table to in this word problem to fill out a table, find the rule, and then use the rule to answer the question. Okay, Rosa plays games at a fair. She can buy 8 game tokens for $1. Each game costs 2 tokens. Okay, 8 game tokens for $1. Each game is 2 tokens. All right. How many games? I need to find out how many games can she play with 120 tokens. Ooh. It's going to be hard to underline that. So I would underline that question. My paper keeps wanting to slip though. Okay. Underline the question. And then we're going to solve for this number after we find the rule. Oh, this is going to be kind of a tricky table. Let me think. So with every $1, she gets 8 tokens. So I think I'm going to make it like for $1, she gets this many tokens. For $2, she gets this many tokens. And then I need to figure out how many games she plays for each dollar too. So that means my top line is going to be dollars. Okay. So for $1, right? And then this is going to be tokens. So $1, she gets 8 tokens. Okay. And then since my question is asking how many games, this sentence right here, each game costs 2 tokens. We need to actually use that to determine how many games she can play with the $1. So I'm not going to put a 2 here. Okay, I got to think, well, if she has 8 tokens and it takes 2 for each game, how many games? Because I want to find out games. My question is asking how many games can she play. So I definitely need one of my lines to be the number of games she can play. So remember, we start off with just the $1. So $1, 8 tokens. That's right here in the problem. But now we have to do a little math for the 2 tokens each game. So how many games can she play with 8 tokens? If they're 2 each, we're going to count by 2s. 2, 4, 6, 8 tokens, and we played 4 games, right? So 4 games for $1 for 8 tokens. So $1, 8 tokens, 4 games. This table's a little different. Do you see what's going on here? In all our other tables, this first number would be multiplied to get the bottom number, but I don't see a bigger number under here. I see a smaller number, so we're going to have to figure out what we need to do for the rule this time. It's going to be different. I can see that already. So let's extend our table a little bit. We've got our first dollar represented. Now, what if she had $2? What if she went to the fair with $2? Well, if she gets 8 tokens for each dollar, that means she'll have 16 tokens, right? And then if games are 2 tokens each, okay, count by 2s. 2, 4, 6, 8, 10, 12, 14, 16. That means she can play 8 games, right? And then if she had $3, I think I'm just going to do 3. 3 can help us find the rule just fine. And then once we have the rule, we'll solve our problem. So $3, she gets 8 tokens for each dollar. That means 3 times 8, she'll have 24 tokens. And then she gets to play 1 game for 2 tokens. So this is going to get smaller. So 2 tokens for 1 game means that we're going to split this in half, and we'll have 12 games that can be played. It's almost like for each dollar she can play 4 games. So 4, 8, 12. We're counting by 4s down here. We're counting by 8s up here. Okay, so now I have some numbers going in my sequences. I need to find the rule that solves from this number to this number, from this number to this number. And this time the numbers are getting smaller, okay? From 8 to 4, what do I do to get from 8 to 4? From 16 to 8, what do I do to get from 16 to 8? It's not going to be multiply this time, because when you multiply by whole numbers, your answer is bigger, and these are not bigger than the top numbers. So what would be something that makes it smaller? Okay, this time we're going to divide, all right? What do we divide 8 by to get to 4? 2. 8 divided by 2 is 4, right? Does that work on this one? 16 divided by 2? 16 divided by 2 is 8. Yes, it is. Does it work on this one? 24 divided by 2 is 12. Yes, it is. So this is my this is my rule. This is my my pattern. So each top number, tokens, is being divided by 2 to find out how many games. So divide is my rule this time. Divide the tokens by 2 to find how many games. All right. And now that we have our rule, we should be able to answer our question. Let's go back to the question. How many games can she play with 120 tokens? So that means we can put it back in our table. So on the token line, if she has 120, okay, we need to find this number. We need to find that. Okay, how many games, question mark, with 120 tokens? Well, to get from the top to the bottom, we have this rule. So we're going to divide by 2. We're going to divide 120 by 2. And 2 goes into 1, no way. 2 goes into 12 6 times, which is 12. 0, bring down the 0. And because I just brought down a number, I've got to divide again. 2 into 0 is 0, which is 0, which is 0. Nothing left to bring down. My answer is 60. So how many games can Rosa play with 120 tokens? She can play 60 games. All right, that is the end of lesson 6, we are using the strategy of solving a simpler problem. Basically, we're organizing the information from the word problem into a table, finding a rule, and then using the rule to solve the question. All right, go ahead and try the practice in Google Classroom and have a great day. Bye.